Okay, these notes are molarity notes. Now, molarity is another way of measuring the concentration of a solution. Molarity uses the moles of the solute, rather than the grams, compared to the volume in liters of the solution. Okay, so we have a couple of equations here we're going to use. Move that up. Now, molarity, which is a capital M, but it's kind of italicized. When you see it on paper, it's italicized. It's kind of hard for me to write italicized with writing, but I'll try. And it's the moles of the solute divided by liters of solution. Okay. Now, we can actually solve for moles of solute or liters of solution, and we're going to use our little upside down P sign where M is the molarity, and then the moles go up here and liters here. And you can actually solve any problem now. If you put your finger over one of them, you got the other two. Like molarity is moles divided by liters. If you do moles, it's molarity times liters. And liters is moles divided by molarity. And if you want, I can show you more tomorrow in class how to use the upside down P sign again. I know we haven't used it since what, Unit 1? So it's been a while. Now, you will be probably going from milliliters to liters, and to go from milliliters to liters, you have to divide by 1,000, because all of your units have to be in liters. Okay, so if you're given milliliters in the problem, you have to divide those milliliters by 1,000 to get the liters. Now, you're also dealing with moles rather than grams, so we're going to have to put the mole bridge up here. So we'll put our moles here and our mass here. And it's just the first half, it's this 1/2 of the mole bridge. Okay, so going from moles to mass, we're going to multiply by molar mass. Although most of the time we're going to be going from mass to moles, which means we're going to divide by molar mass. Because if you're given mass in the problem, you have to convert it by to moles. You do that by dividing by the molar mass. Okay? Okay, example 1. A 100.5 milliliter IV solution contains 5.10 grams of glucose. What is the molarity? Okay, so if we're looking for molarity, so we don't know what that is. Now, the moles, we're given grams. So we're going to take 5.10 grams, and we're going to divide it by the molar mass of sugar, C6H12O6. And that's 180.16 grams per mole. And this gives us 0.0283 moles. And then our liters is not going to be 100.5, but we have to divide it by 1,000. So 100.5 divided by 1,000 is 0.1005 liters. So now our molarity is 0.0283 moles over 0.1005 liters. Now, you don't have to define the variables on this one. I'm just showing you how to do everything. What I need to see in the equation are the units. So I would have to see the M equals 0.0283 moles. Don't just leave the number by itself, okay? And then I want to see the liters on the bottom. And 0.282 molar C6H12O6 solution. Oops. Okay, so I do want to see the liters, or the units in the actual problem. How many moles of KBr should be used to prepare 2.5 liters of a 0.60 molar solution? So we are looking for moles. So when you use our upside down P sign, it turns out that moles is the molarity times the liters. Okay? So here we have our molarity, 0.60 molar solution, and 2.5 liters. So this gives us a 1.5 moles of KBr. Simple as that. This was a very simple one. Okay, this one's a little harder. says how many grams of KBr are present in 775 milliliters of a 0.505 molar solution. Well, with molarity, we're dealing with moles and liters only. So we're going to have to calculate the number of moles first and then multiply by the molar mass to get the number of grams. So once again, my equation is moles is molarity times liters. So my moles are 0.505 molar solution. Now remember, we need to turn the 775 milliliters into liters. So we divide by 1,000, which is the same as moving the decimal places, moving the decimal 3 places to the left. When I do this, I get a 0.391 moles of KBr. But that is not what we want. We're going to multiply by the molar mass of KBr, K plus a Br, and we get 46.5 grams of KBr present. Okay? Okay, last example. To what volume in milliliters should 6.5 grams of KBr be diluted in order to prepare a 0.50 molar solution? So our equation is liters equals moles divided by molarity. So we've got to somehow get moles. So moles is 6.5 grams of KBr divided by the molar mass, which is 119, and we get 0.55, whoops, nope, did that wrong, missing a 0. 0.055 moles of KBr. Okay, so liters is 0.055 moles divided by 0.50 molar, and what we get is 0.11 liters. But I did want it in milliliters, so you have to multiply by 1,000, and we get 110 milliliters of solution. So we have to dilute it to 110 milliliters. And that's pretty much it. That's one example per each type, so hopefully you get this. We'll do a warm-up with some more practice problems. Actually, we'll probably take a quiz first, then do a warm-up, then do some more practice problems. And that's about it. Okay, see you guys tomorrow. Bye!